Alright, Mr. Gatekeeper here, sitting right here with Mr. Kevin's Sweet 16. He's basically saying the amp keeps burning up input combiners. I'm not sure if you're talking about input or output. Most of the time you'll have an issue with output combiners blowing up or burning on you. But you may be talking about input as well. I'll have to wait and see. And upgrade the power wires. Yeah, I can read it better just looking through here. Upgrade the power wires. Input and output combiners, ferrites. This amp's a blank canvas. Oh God, don't tell me that. Hey, if I had more time, my hands wasn't as backed up, buddy, I'd really do some cool things. Which I'm still gonna do some cool things, but you know, I'd have more time to spend on it. But anyway, I want to point out something already that I've noticed. You have 3 different lot transistors in here. And this is nothing abnormal. Sometimes out of older amps, you know, transistors blow. People have to replace the transistors. Now, as you see, you have 2 dot transistors right here. Now, I know a lot of builders, they'll mix dots with non-dots. A lot of technicians, you know, as long as they're matched, you know, all is well. I'm kind of, when it comes to that, I'm a little OCD. I don't really think I've ever had an amplifier leave out of here with dots and non-dots mixed together, personally. But you know, I got a 16 pill over here. It's got mixed dots and non-dots, you know, that runs just fine. But I try to get them matched as good as possible. There's a little bit of characteristics difference from the dots and non-dots just because there are a few things different about the transistor. More or less the heat transfer, the way the heat transfer is doing, because there's no beryllium oxide in the new ones. To be honest with you, the non-dots, the older ones, the heat transfer is a little better. We won't get into all that, but I'm going to show you right here. Now this is an AB biased amplifier, okay, which means there's a bias voltage on all the bases of the transistors when you key it, which means there's a certain amount of current flowing up through the base out the collectors. Okay, now the reason why we like to also match our transistors, because if you have 2 sets of transistors that are not matched, then this set may turn on at this voltage while this set turns on at slightly a different voltage, which means this set right here, it's all Ohm's law, this set right here is going to be pulling this amount of current while this set right here is pulling this amount of current. And I'll show you an example of that right now. Alright, I've got it to where I can manually key the box. I'm just going to be connecting it to the ground like that to key it. And I want to show you just by the voltage end of things. We're going to check this 2-pill section and on down. Okay. You see that's 0.65 volts. Okay. Alright, let's check this 2-pill section, the next 2-pill section. 0.62 volts. Sorry about that. It was recording on my internal storage and I ran out of space. Y'all hear me say it so much. Yes, I need to upgrade my phone for one thing, and also I need to get some bigger micro SD cards. Alright, the third 2-pill section, 0.6263 volts. Now look at the 4th 2-pill section, the dots. Look at that, that's all the way at 0.69. It was showing 0.7 a second ago, but 0.69. So that's like basically this 2-pill section right here is going to have the most current flowing, because whatever volts that it's at all has to do with how much current is being pulled. So it would be ideal if each one of these sections were identical. .65, 65, 65, 65, or whatever, you know, .68, .68, .68. And they should be, right? All the components in each voltage dividing circuit is the same. I mean, you might have a different voltage drop here and there that might throw it off a tad bit, but the reason why is, the main reason why you're seeing a different one in this particular issue is because there's 3 different lot transistors in here. Let's just see this for the heck of it. This section right here, these are the same transistors, .62, .62, .63. You see how them two are pretty much equal? That's because they're the same lot transistors. See that? 5F, 5F. So they're the same exact lot transistors, probably the original transistors. So that's why their bias current is the same. Right there at the same. And these two are different. They're different transistors. So it looks like you just probably got a simple issue of unmatched transistors. Luckily you sent me some, which I don't know if that's going to help much. I know you sent me 2 brand new Toshibas. I don't know if that's going to help or hurt the situation. I'm going to be pulling these first, and we're going to see if we can't get some dots in here. I've got to check the gain on all these bad boys and see where they're at. But so I'm gonna work on that first. I've not even keyed the amplifier or anything yet. The first thing I always do is check the bias current, check the base voltage on all the transistors. First off, make sure they're not anything catastrophic like the 667 was. I think it was like 1.5, 1 point something volts. That's quite a bit of milliamps on the base of the transistor. Alright, I ain't gonna try to bore you too much more with all that information, but we'll get it straightened out for you, bud. We'll get it straightened out for you. Alright, I'll be back. Oh, I'm recording now. Let me take a sip of this monster. Oh yeah. Alright, bud, I want to show something to you. Ooh, using my head apparatus here. First thing I noticed was this thing wasn't keying up. The bias relay was not actuating, which wasn't actuating the main relay. And I was trying to figure out what it was. First thing I did is change the keying circuit, the keying transistor. That wasn't what it was. And I pulled the 15 picofarad cap. That was fine. I was like, what in the world's causing this? And I sit here and looked over here in this direction. I don't know who done this. I'm trying to think electrically what they were attempting to do with this. I've never seen anybody do this before. That's why I say that. See if we can't zoom in just a little bit on there. See, now this is what it was doing. Let me turn the power on here. Now watch the relay. I'm going to key the microphone. See it? It's not actuating. Now when I audio, it may actuate. I'm not even going to try that. So I thought about it, and I was sitting here looking at this capacitor right here. I can't tell what value it is. Some sort of box capacitor. Now watch this. Now, and like I said, you may have been using this amp manually keying it with this. I don't know. I hadn't talked to you about that yet. But, and this does not need to be here for this. You don't even need a resistor here for this either. Although it works fine with the resistor. Because you're just giving this relay a ground. And that's all the transistor is doing as well, is giving it a ground. A direct ground. Like literally directly from the ground plane of this board, the transistor is giving this relay a ground directly from there. There's no reason to have a resistor or anything right here. But if you check it out, it's the first time I've ever soldered on camera. Let's just lift it up, lift the leg up. Now look. Key's perfect. So that capacitor was causing it not to key, because if you look, this is soldered in right here before the 470 ohm resistor. You could actually just take this and solder it directly to the ground of the relay, but you know, that's fine as well if you want to do it that way. And it was throwing it off, causing the relay to not, causing the key insert to not work the way it's supposed to. Now I'm sitting here trying to think electrically why it was doing that. But if you ask me, I think what was going on is it was possibly shunting all the RF to ground. This capacitor is probably such a high value, or whatever value it is, it was shunting all the RF to ground. So basically there was not enough RF even getting to the transistor to keep it biased on, because it's taking the RF and actually biasing the resistor with it. So keeping it on, keeping the ground going to the relay. All right, now we can get this thing keyed and check it out. So I'll be back. All right, brother, found your problem. You got yourself a blown transistor, and of course no 10 ohm blue. Under this type of configuration with these Texas stars, a lot of times you won't see the 10 ohms blow, because it's sitting up under multi-level of combination, the way they're combined. But that 10 ohm was getting very hot, in conjunction with the old trusty infrared thermometer and the old bird meter there. I was able to pinpoint which two-pill section, because my oscilloscope is currently broke right now, so I'm having to go back to the old ancient methods of operation, shall I say. Well, anyway, I think this is the good transistor. Yeah, this is a good transistor right here. 16 HFS 16. Keep in mind, we only use these little computers right here for reference. You know, they don't put a strong load on the transistors. And 16, let me remember that. Put it right here. Alright, here's your other one here. I want something that fell out of my lap. Oh boy. Sitting here watching it through the viewfinder here, or my screen on my phone, shall I say. Alright. No component detected. It's blown all the way through. Alright. So I don't get confused myself, I always like to write big X on blown transistors so I don't get them confused. Alright, man. Let's look through your bag of goodies and see what we can work out. I'm gonna go ahead and tell you now, man. I'm gonna get this bad boy fixed for you and all, but I suggest, if you have any more issues with a blown transistor or something like that, if you're able to, replace all 8 transistors. You know, either HGs, Toshibas, whatever. Just replace them all 8 of them, so they can be all matched if you have any more problems. I'm going to try to rectify this issue the best way I can with what I have. and we'll get the power wire upgrade done for you. So far, a lot of the power wire upgrades I've done on Sweet 16s have been also ones that have been converted over to Class C, so it gave me a lot of room right here in this section. So I've kind of got it worked out in my head how I'm going to do this for this one. Just going to, you know, keep it simple, straight to the point. I'm not going to use a bus bar or anything like that. We're going to do it the way I do the 667s. Updated wire to the buses with a choke to each transformer. I give you a little bit of inductance on the power wires. Because right now, the way this amp sits right now, I mean, there's hardly no inductance on the power wires at all. There's hardly nothing keeping the RF from flowing through the ground wire. I've never even tested one of the Texas Star's chokes that they use to see how much inductance they're sitting at. You know what? I'll do that while I'm doing this. When I remove these right here, I'll check them up and let's see. The basic rule of thumb is try to get around 500 ohms, the lowest frequency that you're going to be using. That is the rule of thumb if you want to do it by the book, but we also have to remember what operators these amplifiers are for. Oh, Gatekeeper said it. We'll be back.
On a spinning flying saucer.
All right, big brother. We got you all fixed up here. So I'm going to go ahead and, sorry, I know that's kind of loud in the background. Listen to some entertaining, crazy things. It keeps me entertained while I work. But, oops. I'm going to go ahead and do the power wire upgrade now. Probably going to take me about 2-3 hours to get this done. But, kind of got it in my head how I'm going to do it. So, go ahead and get into that now. So far, everything went pretty smooth. And I'm not picking up any excess heat on the combiners yet. Due to any imbalances due to the different lot transistors. But I went ahead and put you two in here. The same lot that was already in here. Luckily, you had a transistor, I can tell, that came from here. And it actually matched that one. So now, you know, these four match very well. So that's good. That's better than I was thinking it was going to be. All right, let's get this power wire upgrade and get to the third amp, man. All right, man. We'll be back. Alrighty, Mr. Gatekeeper here. Back. Finally got this joker all finished up. Let me turn my buddy Tech 9 down a little bit. Got one of his videos rolling. Hanging out with old Tech while I'm finishing up this box here. This Texas Star. Well, anyway, let me go ahead and press pause. I won't be able to concentrate, man. He's doing an interesting build there I'm checking out while I'm working. Anyway. Whew, I did a lot more than I anticipated. I just kind of went with my heart. Because you did right on here. This amp is a blank canvas. Do anything you want to do with it. You shouldn't have said that, bud. Whew, man. Well, as you can see, we got the power wire upgrade done. Ooh. This is what came out of it. One 8-gauge ground wire. And 1, 2, 3, 4 12-gauge wires. Now what you have is 4 good stiff 10-gauge wires. And whatever I say stiff, I don't mean the wire is actually stiff. That's just a word I use, meaning it's some good thick 10-gauge wire. And instead of having one 8-gauge wire, you now have for the ground you have 2 good 8-gauge wires for the ground. That's about the best way I could think about doing this, the way that I've done this particular style of power wire upgrade, full power wire upgrade. All of these have been removed. And has been replaced with more than twice the size wire going to the back of the transformers. So that's 14-gauge wire right there. And I'm gonna tell you what, it was a chore to get these strain reliefs to fit. I will be honest with you, I thought I had done made a big mistake in calculating these holes, but somebody was looking out for me and it worked out. I had to do a little bit of modification inside here and make the actual plastic nuts a little smaller. It tacked on a few extra hours, I will say, but the main thing is I got them on there. Keep them good and sturdy. Alright, one thing that I did so we wouldn't have a lot of wires all bundled up together in one place right here, I literally moved every single wire. These were the factory wires, as you see right here. Carrying the bias for the fans, for the sideband delay, so on. I went ahead and repositioned them now to over here, as you can see. So all these wires now travel this direction back to the fan and the remote. It's like 4 times as thick as it even needs to be for the carrying the RF over to the keying circuit, and I replaced that too, just kind of because this choke was going to be in the way anyway. So I went ahead and replaced that with a more wire that, you know, it's perfect size for carrying that little bit of RF over there to there. Whew, man. So yeah, I rewired pretty much the whole power wire system completely. And another thing I went ahead and done was the manual keying. As you can see, the manual key port RCA connector was right here. Okay, so I moved it over here, as you can see right there. Okay, and I went ahead and rerouted that wire because, for one thing, it wasn't Teflon. When you're dealing with these type of amplifiers, it's good to always use Teflon. Okay, especially if the wire is going to be sitting on a frame or anything that's connected to the heat sink itself, because that wire, this box can get so hot that wire over time can start melting and short. But in this case, it wouldn't really cause any issues probably. If it's shorted against here, your box would be keyed up, which still could cause some issues, no doubt about it, but not with a electrical short, fire hazard, anything for that particular wire. But I went ahead and rerouted it. Instead of running from, you know, here all the way there or whatever, I went ahead and rerouted it the shortest length possible here to here. Okay, so it turned out real well. I thickened up all the solder spots on the boards, which means I put a lot. I thickened up the solder on all of them just to give a good, more thicker space for the current to flow through. I always do that on the Texas Stars. You might have this much, you know, to where it's just paper thin foil. You know, you go ahead and thicken up with some solder, it's going to, of course, be able to handle more current. So, and that's what we're trying to do, is get all the current that it possibly can get to each 2-pill section. Alright, another thing I went ahead and did, as I shortened this wire up right here and rerouted it, just to kind of make everything flow together a lot better. So I shortened it and dropped it down where it was, but just in a different angle with a little bit less wire. All right. I think that's about it, bud. So yeah, man, it's beautiful. Look at it, real nice, clean. I guess I probably could put a tie strap right here, but other than that, man, I mean, it looks good. Try to keep the power wire off these sandbars right here. These sandbars can get so hot they'll burn the dang skin off of you, and I'm not kidding. I've done it. I have done it. I think it was on video too. The only other thing I can think of that I had to do was these right here are 100 microfarad capacitors. Okay, they're just for a little bit of filter on the bias. Okay, the one right here was going to be getting in the way of the strain reliefs here. So what I went ahead and did was went and got me another 100 microfarad electrolytic, because as you can see, these are all the parts that came up. I just went and took these box capacitors off. Somebody added them. There's already a filter cap on the hot bus, each hot bus. Here it is. Once I removed it, the leads were so dang short, man, I wasn't going to be able to resolder that. So I went ahead and got me another 100 microfarad cap and just repositioned it. It's kind of hard to see down there, but I repositioned it for you, Kev. There it is. See? I repositioned it. It was sitting right here, so I just repositioned it over here on this side to stay out of the way of this. So I had to do a little bit of modification, a little bit of retrofitting, so on and so on. Alright, about the best power supply I got right now that I can use is this one right here, which is always dark. I can't never really see if I can't get my headlamp, take my headlamp off and shine it in here. That's a 100 amp transformer. That's a 100 amp transformer. See if I can't turn this on a little bit brighter. Yeah, she's trying to get into the camera like always. Yeah. So this is 16 field being fed with two 4-gauge wires. I don't really like that. I'd rather it be fed with two 4-gauge power wires, two 4-gauge hots, two 4-gauge grounds. It's just fed with one 4-gauge hot, one 4-gauge ground. But anyway, that is a pretty strong 200 amp supply. It's probably more like 250 or something, but so we're going to be running on that, and I will be honest with you, just hitting it with the 1 pill, which is all I plan to hit this box with. I'm not going to hook the 2 pill up or anything. You don't have to hit these boxes hard to get them up and going. This box is already doing 600 to 700 watts peak on 14.4 volts. Just driving 4 watts RMS into it. I mean, that'll show you what an amplifier will do with base voltage. I'm tired as all get out. If I say anything wrong or whatever, just forgive me. I have literally been up since 10 o'clock yesterday, and it is now 6:33 in the morning. I need to go get my butt in the bed, but I want to get this video out of the way and get it uploading. Might have to do, probably gonna have to do another 1 or 2 repairs in between this one and your next box. Had some emergency come up. The guys pretty much drove down here, and he's done got himself a hotel. He thought that I ran a commercial shop here, and he literally just showed up. I ain't gonna get into it, but I can't just send somebody home that's been driving that far. He got some bad info from somebody, basically telling me he could just drive on down here whenever he wants. You know, I work. Look, everybody. Old Gatekeeper works from his residence, my private residence, in this nasty A garage. I do not run a commercial business. This is a hobby business of mine. It's not okay just to show up uninvited. If you local or whatever, contact me first. We'll work everything out. Just don't never just show up, please. Alright, buddy, my phone actually quit recording because it overheated. Can you believe that? It's 6 o'clock in the morning. Well, anyway, we're going to hit it with a 4-watt radio at first, okay? The driver, just a single 2879. First build I ever did. I think I'd make time to put a decent fan on that, or cover that hole, or put a new lid on it, wouldn't you think? Driver's on 14.4 volts. Alright, I'll go ahead and let you know, just hitting this thing with the driver, it's not really going to pull the voltage down to a real good voltage that I'd be running at. It's like 16 volts. I'm just going to hit it real quick just to show you what it's doing just with a small 4-watt radio. When I hit it with the little stronger radio, it'll drop it down to a good safe voltage then. Alright. The radio is 1000-watt slug. I mean, the driver is about 40-50 watts RMS. It's going to be going into it. Alright, go ahead and flip on the Sweet 16, 1000-watt slug, reading the bottom scale. Got about 180 watt dead key. Right there, about 580. Peak, of course, goes off the scale over 1000 watts. Alright, I'm going to go ahead and hook up the hot radio. And keep in mind, man, we just drove it with like 40, 45 bird probably. About 80 to 100 watts peak. Not that much drive for this bad boy. I'm pretty sure once we hook up the hot radio and bump up the drive to about, let's see what it bumps it up to. Give me 1 second, I'll hook it up. Alright, we've got the hot radio hooked up now. All we're doing is doubling our input drive from 4 watts over to 8 watts RMS. We're going to be hitting this driver with about 30 to 40 peak. But the RMS is what you really want to look at. This will drop the unregulated supply to a good safe voltage around 15 volts or so. Alright, we're now going to be putting probably about 60 to 70 watts RMS. Okay, so this should drive it pretty decently. I don't know why I just turned the peak on. I'm so tired, y'all. I meant to turn the box on. Alright, let's see what this bad boy's gonna do. I haven't even keyed it yet, so I don't know. This radio, 1000-watt slug still. We'll hook it up 2500 watt. And of course, I forgot to show the input reflect. It's great. It's barely moving. I keep forgetting to show that here lately. Alright, focus. Alright, bottom scale. Wow. Right there, yeah. Alright, my phone overheated again. It's getting a little on my nerves. I just sat there and showed the peak and everything and just talked for about 5-6 minutes and looked up and noticed it wasn't recording. And I unhooked everything and everything. That's how tired I am, man. Alright, we're showing the peak now. It was doing 1000 watts RMS, and that's just hitting it with a 1 transistor amplifier, man. That's awesome. Awesome. Alright, here's your peak, 2500 watt slug. Okay. We're reading the top scale. It's gonna be doing about 1750, I already know. So I'm gonna turn my radio on. See, I done turned everything off. I was about to hit the sack. Alright. There we go. Oh. No, I ain't got the driver on. Goodness. Well, that shows you right there, just hitting it with this radio. It's already doing 1,000 watts. Just hitting it with the radio. Goodness gracious. With the driver on. I'm not even going to say it. Yes, it overheated again. I'm just trying to get this junk done so I can get into bed, man. Driver now, bud. Driver's hitting it. Let me show that 1700. Go. Look at that, 1750 watts. And I'm going to say, man, this thing is rocking and rolling, brother. That's on, about 15.7 volts, which is still a little stiff. But this supply right here I'm running off of is a little bit stronger than the one I normally run off of. But anyway, man, most of the time you have to hit a Class C or a regular 8-pill with a 2 transistor amp to get it to do that amount of power. So that's awesome. This thing is working great. It's working great. Most people wouldn't have done all of this extra work. I thought I was about to turn off again. You know, I just went with my heart, man. That's all it is. I didn't have to do all this wire rerouting. I know that. I could have just left everything, but I just go with my heart, man. Whatever, if I feel that needs to be done, I just roll with it. You know, I won't even ask any questions. I just thought since it's going to have a little bit thicker wire here, I mean, all that extra wire here is just going to take up more space right here and just look more, you know, look worse. And I think that looks a lot better and a lot more uniform done like that. You know, a lot of guys tell me, you know, quit doing all that extra stuff, just get caught up. Look, man, I'm over a year plus, a year and a couple of months backed up on builds. I really am. It's embarrassing, but I am. I'm working hard as I can to get caught up. You know, like I've had people tell me, dude, just rush through them repairs, just get them done, don't do videos, da-da-da. I just can't make myself rush through something and not do the best that I possibly can at that moment on it. I've tried. I ain't gonna lie to you. I've tried to just rush through a couple of small repairs, but I still find myself just spending time, you know, and cleaning stuff up. I just finally said, you know what? I'm just gonna have to do what I do. It don't matter how backed up I am. I'm gonna have to work on the amp the same if I had none behind this amp or if I had 100 behind this amp to do. So I mean, and like I say, I'm not never the one to brag at all, period, because there's many people 10 times better than I am out here, man. I'm learning. I'm always learning. I'm open-minded. I've been in this thing for quite a few years now, but nowhere near the amount of years of some of these other builders have been in it. I still look at myself as the new kid on the block, but even though there's a lot more new kids on the block popping up out there, especially since these HGs have hit the scene. It's an HG nation, baby. All right, brother, we got it done, man. Turn this supply off. This thing ain't turned off, luckily. I always do this for everybody's amps. Yes, it does take more time to do, but I always do this. One thing, I can clamp on it better with my clamps, but the main reason I do it is you're ready to put an Anderson finger on it. An Anderson finger. You ready to put one of them old there Anderson fingers on there. You know what I'm talking about? One of these things right here. One of these old Anderson fingers. I don't know what to call them. I think that's what they're called. Fingers. Fingers. You can put one of these fingers on there easy. Now they're already tinned up. You just get that vice grip, hold that there finger up like that, put that there liquid paste up in there, that silver liquid paste, and you know it's already tinned up, so you just put that bad boy in there and fill that cup up at the end of the butt of that finger with solder, and you got yourself one ready to plug into an old Anderson connector. I don't have any 175s laying around, bud, but I'll shoot your connectors back to you. These bad boys look brand new too, man. So I'll shoot them back to you, man. But they're already tinned up, ready to go. You can cut a little bit off if you need to. I'll put some heat shrink on here for you before I ship it out to you. Only other thing is, I need to ask you, I don't know if you have a plug or something for these fans to plug in. Because look, let me show this real quick. One of my buddies came over and looked at this, and he said that he had seen a video that BBI did, Mr. BBI, out there in Idaho. And he said that BBI had repaired a Sweet 16 that had one of these on here. Right there. That. The only thing I can think of just by looking at it is some sort of regulator. I popped the top off. I see some surface mount circuitry and a couple ICs in there. I mean, I hadn't put I have put voltage to it, you know, to this plug, and the fans are coming on just fine. But I don't know if you have a plug that you've made up or something that plugs straight into the fan port back here. Just let me know if you don't. I'll make you one up. I think I got a couple of these plugs out there. I'm not the biggest fan of these plugs right here, but they're good for this kind of stuff, I guess. But I can make you a quick adapter you plug straight into there. But he had just mentioned that. I think he said he had seen a video BBI had did. I can't remember if he said BBI installed one of these or they had them on there. I can't remember. But he had just mentioned that to me. I hadn't seen the video myself, so I've never seen one of them myself. There's a lot of accessories out there for fans. Oh, boy, I'm hitting the goddamn sack now, man. If I forgot to say anything or I left anything out, it's just going to be out. You know what I'm talking about? Let's go ahead and get this Y-mote technology right here and shut this goddamn lights off. I'm out of here, man. I'm done for. I'm about to hit the flat side, as they say. Alright, old Gatekeeper said that. Another Texas Star repair in the bag. And I'm sure many, many, many more to go. We'll get to your 1600X pretty soon, bud. Like I said, I'm going to have to do two repairs in between. Got a little emergency going on here. Somebody's up at the hotel up here locally. I'll get them done here today. Alright, bud. I'm gone, man. God bless. I'm going to the flat side. I'm going to Sleepy Lands. Gatekeeper is going to Sleepy Lands. God bless. Peace. Bye-bye.